Well, welcome to our breakout session, Efficient and Effective Assemblies. My name is Adam Benson. I'm one of the application engineers at Quest Integration. And this breakout session was one of the many that we offered in our Tech Day 2015 event earlier this year. And it was actually one of the more popular ones that you guys chose. So I hope you enjoyed the content that I've put together here. Let's go ahead and get started. Here we've got some topics of interest. Things that we'll cover include controlling external references, tips to increase productivity, how to approach mate errors, and managing our large assemblies. And I'm just going to start right off at the top of the list, work our way down, and we'll make our way through this PowerPoint. So before we get right into external references, what they are, how we can manage them, I want to bring up this external reference search order. So how SolidWorks is looking for those reference documents. This is something that I get asked every so often, and there is an order in which SolidWorks is looking for these documents. And here it is. I'm not going to go through each item on the list. Definitely a great chance for you to grab a quick screenshot and use for reference down the road. So what are external references? We create these external references anytime a feature requires information outside of the model to be able to update. And typically we see this in our top-down assembly modeling. So during top-down assembly modeling, we're creating these parts in context of the assembly. So the size, the position, the shape of these parts are based off of other parts or other components in the assembly. And by doing this, adding these references, we're creating these in-context features. And in turn, what that's doing is it's creating update holders in the assembly. And we'll talk about that a little bit later. Now, something else that this brings into play is the part is not going to be updated unless assembly is open. So if we see changes in the assembly and we just have the part open, we need to actually open up that assembly to see those changes as well. So how can I tell if I have an external reference? Well, if we take a look at this table, a great way to identify this is right through the design tree with the symbols. And many of you guys may have seen these symbols before, and you might not be sure exactly what they mean. Well, here's a chance to get familiar with those. So taking a look at the first column on the left, we have our symbols. The external reference is noted by the arrow after the component name or feature in the component. And then we have a particular status, right? And then I've also got a little bit of a description for these. So with just the normal arrow, we see that the status is in context. What that means is the file, the referenced file, is open, and that feature, that component, is up to date because it is open, so it sees those changes. If I have a question mark after that arrow, the status is out of context. So the reference file is not open, so we don't know if that feature, that component, is actually up to date or not. We could also have a locked reference, which is noted by the asterisk after the arrow. That means that the reference file has been locked. We've temporarily removed the external references from that particular file. We could also have broken references. And we see an X after the arrow in the design tree that tells us that we have a broken reference. This is kind of the easy button here. We've chosen to break the external references, so permanently remove those. We can also use list external references. So anytime I see those symbols in the design tree on a part or a feature, a sketch, you can right click on that and choose list external refs. And it'll bring up this list external references dialog, and this shows us some detail about the external references. So in this case, the assembly that it's referencing here, the feature that is involved with the external reference, how the information was created for that external reference. So in this case, we converted some entities from an existing component in the assembly. And it also tells us the status and gives us some information as far as the reference entity as well as the component. From here, we can also choose to break the external references or lock the external references. So that brings up a couple questions that we may ask ourselves. When should I remove external references, and how do I remove these external references? Well, we should remove these external references anytime that we have movement for that particular component in our assembly and it's not in line with the reference geometry. This can cause our in-context features to fail at this point. Or if we are planning on reusing that component in another assembly. If I have a part that is defined in assembly A with some external references in context features that are looking at changes to assembly A, and I use it in assembly B, any changes that I make to assembly A are going to affect that part, and in turn, because that part is being used in assembly B is also going to be affected. So we want to be aware of those and help avoid those unintentional changes to those other assemblies. So how can I remove these external references? Well, we already took a look at a couple there. We can lock to temporarily remove the external reference. This is kind of nice in case I want to take a look at how this part may behave if I don't have the external references there. And then at any time I can go back and restore that. We can also, like I said, hit the easy button and we can break those external references right through the list external references dialog. These cannot be restored. This is a permanent break. The clean way to do this is to actually find where that external reference is, why we've created that external reference. Is it a feature? Is it inside of the sketch? Do we have relations relating to other components in the assembly? We want to find that and then utilize the tools in SolidWorks to remove those references. So whether it's deleting the relations and redefining the sketch using internal relations and dimensions, however we want to do that, we can go in there and remove those manually, and again, that is the cleanest method. Another way to do this is to save as copy. So if I perform a save as copy, the file is still referencing back to the assembly, but those references are out of context, and I no longer see any of the changes to that assembly. So in-context features. These are features that are created by referencing any geometry outside of the model in itself. And again, typically we see this with top-down assembly modeling. Like I mentioned before, we're creating a part that's inside of the assembly. It's referencing other parts in that assembly. And this creates update holder features in our assembly. And by default, these are turned off or hidden from us. So we don't see those in the design tree. We can show them if we want. You can right-click at the top of the design tree and choose Show Update Holder Feature. But it's really not necessary to show those in that design tree. But it is important to understand that this is the link that is created for our components to look at the assembly and make sure that everything's up to date. So every time we have that external reference through these in-context features, we're creating those update holders. And again, this only updates when my assembly is open. That's important to know. And so if I don't have the assembly open, we're going to see that question mark there telling us that the status is out of context. If you right-click on a in-context feature from the part, if you don't have the assembly open, you can right-click on that feature, choose Edit in Context, and that will open that assembly up for you. What's nice about in-context features, provides a great way for design automation. We can create that in-context part based off of other components in the assembly, and then down the road get rid of those in-context features, get rid of those external references and how we've defined that, maybe redefine it with some dimensions and internal relations. And this is really best used for one-of-a-kind parts. Right? Again, we go back to taking a look at two assemblies and using this part in multiple assemblies. If the part is defined based off one assembly, we make changes to that assembly, it's going to affect the part and in turn affect the assembly or assemblies wherever that part is being used. So we definitely want to be aware of that. So let's take a look at some tips to increase productivity, and we're going to go through a couple items here. We'll take a look at a list here in just a second. I'm also going to jump into SolidWorks a little bit so you guys can see some of the mouse clicks there, where to find some of these items, so it's a little bit more familiar. We're not just sitting here staring at the PowerPoint. So tips to increase productivity. We're going to take a look at some mate techniques, smart components. I want to review smart components with you guys, let you know the benefits of that, what is involved in creating those smart components. Replace components. I want to make sure that we, if we need to replace a particular component in our assembly, that we are doing so correctly. So we'll take a look at some of the different options that we have available for that. And then also the pack and go, or if you're using Enterprise PDM, copy tree. So here's a list of some of the different mate techniques that I've wanted to bring up. Some of them that I use, find very useful for the automation of creating some of these different mates. The first one that we have is multiple mate mode. With this, I can create several mates automatically, utilizing a common reference between those mates. And we'll take a look at that in just a bit. Also, smart mates. There's a few different ways that we can take advantage of smart mates, and again, this automates the creation of our standard mates. So if I have an open document window as well as my assembly, I can drag that document from that open window and drop it into my assembly, and that is utilizing smart mates when we do that. Automatically, I don't need to hold down any keys, I don't need to do anything else. Simply dragging and dropping into the assembly window is utilizing smart mates. We can also, if I've already inserted that component into the assembly, hold the Alt key and drag one of the referenced geometry that we're going to use for mating onto another component in the assembly to trigger the smart mates. One that I like to use can be found in the move component command. This one I'll show you guys. Another way to activate the smart mates there, it involves double clicking on the mated geometry. And then we'll take a look at mate references. Right, so when we're inserting these components, it might be kind of nice to have it just snap into place, maybe concentric to a hole or coincident to a flat face. And we can do this by utilizing mate references. And we have a few different types of mate references. We have a standard, just regular mate reference. We also have named mate references. And we can also capture a mate reference. So if we've already inserted a component into an assembly and we've created all the mates, and we want to then add those mates as a mate reference to that particular component, we can utilize capture mate reference to do so. And then creating additional instances of components in our assembly. How often do you find yourself inserting these components over and over again and creating the same mates over and over again? It's a real time killer if we are not utilizing things like copy with mates. So copy with mates can be used to copy those components and then redefine the mates that are already used. So we'll take a look at that as well. Let's go ahead and get right into SolidWorks and take a look at some of these different mate techniques. Love utilizing the recent documents list, just the R key on the keyboard. Quick little tip there. You can also pin those documents, so if you're working on a particular project, for a week or two, same files, you can pin those so you don't need to go look for those each time. But here we've got a bearing, a sleeve, and a gear that are all going to be concentric with this output shaft. And so a quick way to do that is to utilize multiple mate mode. And we find this by taking a look at the property manager for mate. You'll notice that I have a little button here for multiple mate mode. If I click on that, it changes the property manager just a bit. We now have two selection boxes here, one for common reference and one for our component references. So my common reference is going to be the output shaft, and then my other references here are going to be each component. And so as we select these, we can select the type of mate that we want to create there, and then once I've clicked all those additional references, I can simply hit OK to add those 3 additional concentric mates to the list of mates. Go ahead and finish defining this. Love those quick mates, right? Holding control, as soon as I let go of control, I get the context toolbar, which I'm sure a lot of you guys are familiar with. Great shortcut, and now we have access to those quick mates. If you ever move your cursor off of this, though, you know that it disappears, right? And if I move it back, it doesn't come back. And that is the default. You know, we've seen this before. Great tip, kind of a little secret there. If you move your cursor back over where that context toolbar was at, hit the control key on your keyboard. That'll bring that context toolbar right back, and then you can add the necessary relation. We'll go ahead and add a parallel relation there. Make sure things are good. Next, I have a few different components that I want to go ahead and add some mates between, and we can do so with smart mates. So like I said, another way to activate our smart mates here is right through the move component command. So you'll see that I have a smart mates button. If I click on that, that activates my smart mates, and this method involves double clicking on the component that I want to mate, and then single clicking, and in this case the face that I'm going to mate that component with. And then I simply just choose the mate, hit OK, and we're good to go. And it keeps it active so I can continue to add additional mates here quickly and easily. We'll go ahead and position this gear so it's centered. Again, another way, if I hold the Alt key and I click on a face in this case and I drag it, I can drag it and drop it onto another face of a part, and that'll activate that smart mate as well. So we'll position our shaft and components in the center of that gearbox. Now I've got a bearing here, a sleeve here, and I need to have 2 more of those on the, or 1 more of those on the opposite side. So a great opportunity for me to utilize mirror components. Mirror components, anytime I have symmetry, anytime we can take advantage of patterns, we should. It is very efficient and saves us a lot of time for inserting and positioning these components. So just like that, I've created the additional bearing and sleeve component in there. At this point, let's go ahead and take a look at mate references. So I'm going to bring up that recent documents list again. I've got a cap component, and we'll go ahead and open that up. You will notice in the design tree here I have a mate references folder, and underneath there I've created a mate ahead of time, and we'll take a look at that in just a second. But first, let me show you where we can find this. If you take a look under reference geometry, you will see mate reference, and I can create multiple mate references for these parts. Let me jump back to the assembly really quick. Where we're going to place this cap is right on the end here of this outer casting for our gearbox. So really what I want to show here is the ability to create these mate references to just have these components snap into place right when we insert them. So let's go ahead and take a look at it. Now for this, I am utilizing what's called a named mate reference. So at the top of that mate reference, we can give it any name that we want. And to use the named mate reference, I need to also have the component in the assembly that I'm going to mate to have the exact same mate reference with the exact same name and the exact same references selected. So in this case, it's a named mate reference. If I were to create just a regular mate reference, I have multiple, 3 in this case, references to choose from. So a primary, secondary, and tertiary. And the way that SolidWorks uses these mate references by default is it looks at the first face and then the mate type that we've chosen. And when I bring this part in to my assembly and I hover over a face of an existing part, it tries to make it concentric with that face. If it can't make it concentric with that face, it jumps down to our second reference, which is this face here. It'll try to make it concentric with this face. If it still can't do that, it'll jump down to our third reference, which is the back face here, and it'll attempt to make it coincident to the face that we're hovering over. And that's how our mate references work. Now in this case it's a little bit different because we have a named mate reference where I've set it up in such a way that we've added a name, added our references, and then also inside of our outer casting, which is what we're going to mate it to, I have created the exact same mate reference. So if we do this, we can create what's called a named mate reference. And this allows us to take advantage of inserting this part and having it automatically snap right into place into the assembly on that outer casting. So let's go ahead and take a look at it. Go through Insert Components, I bring my cap over, and notice that as I move my cursor into the graphics area, as soon as I get into the graphics area, it snaps it into place. All I need to do here is click, and I've placed that cap, and it has also added the 3 mates that you can see there. So great way if I've got components that I'm inserting all the time. They are connected in the same locations for each maybe project or design. Now we can set up a named mate reference to have that automatically snap in place. Now let me show you guys a really quick copy with mate. So I've got this cap. I want a cap on the other side as well. Sure, I could utilize a mirror in this case. I could insert another instance of it. But let me just show you guys copy with mates. So copy with mates, like I said, it allows me to select the component, the components, and when I say component, I mean part or assembly. So we can copy these. I can move to the next option or set of options in our property manager, and then it takes a look at redefining the mates for this copied component. So in this case for my cap, I've got a concentric hole up here, a concentric hole over here, and then I need to be coincident with a face, which is going to be that face there. And as soon as I click OK, we've then positioned another instance of that cap, and it has simply just recreated those mates for me. So great way to automate the insertion of those additional instances of components and recreate those mates as well. So we took a look at some different mate techniques to help us increase our productivity from day-to-day work. Now I want to show you guys smart components. So what's really beneficial about smart components is this contains more information than just the part itself or the assembly, because we could also have a smart assembly. And so we can bring over additional components, we can bring over features into this assembly when we insert that component. And what's really nice about this is there's no external reference to the defining assembly for these smart components. And it dramatically speeds up the insertion process for some of these common parts that we have. So let me go ahead and show you guys an example just so you can see, again, go through the mouse clicks inside of SolidWorks. So I've got a motor mount that's going to go on our gearbox here, and if we take a look at this part, it looks, you know, like an ordinary part, but taking a closer look over here in the design tree, I have a smart feature folder. Right? This tells me that this is a smart component. You'll also notice that the icon has changed. It has a little star next to it as well. And so that tells me that this is a smart component. And if we get in and take a look at the defining assembly, if I want to create a smart component, I simply just need to insert this into an assembly. And this assembly is really just a dummy assembly if we want it to be. It could be the component is already inserted in an assembly and we want to make it a smart component. If I go to Tools, you will see Make Smart Component listed in there. Now this is already a smart component, so I'm just going to get in and edit the definition and show you what the property manager would look like when you hit Make Smart Component. So it brings up this property manager, and what we're looking at here is we need to specify what component we're going to make smart, so whether it's a part or an assembly, and then what components we want to have included with that smart component. So in this case, we've got some bolts that are going to bolt this motor mount to our gearbox. And then we also have features, right? I'm going to have it drill some holes for us into that gearbox as well. And so really, I mean, that's it. We set it up, choose to include the components, the features, save it out, and then the next time we go and use this, we can choose to insert those. So let me jump back over into our assembly and we'll take a look at how that works. Again, I've got a named mate reference there, so it snaps right into place for me. And as soon as I do that, you'll notice that there's a little folder here. If I click on that folder, this is going to bring up my insert smart feature property manager. And so what this is asking me is what features I want to bring over from this smart component, as well as what components I want to bring over. And it's looking for a reference face for those holes that I have for that feature. So I simply just need to come into this model, find that face, select it, and SolidWorks will place those bolts as well as create the holes for me. So a great way to save time on inserting these components, inserting any additional features that we may have. And if we take a look at hiding some of these components, again, if you hover over a component in an assembly, hit the tab key, that is a shortcut to hide. Hover back over that hidden component, hold down shift and hit tab to bring it back. And you can see there, it's created that hole for me. So quickly and easily, right? I insert a component, choose to insert the features, pick any references that I may need to position those, and I'm good to go. So as you can see, I mean, that can really speed up the time in inserting some of these components, especially for those common parts that we have that are bringing over, you know, additional hardware. So how can we replace some components in our assembly? All right, what if I have an assembly and I want to replace it with a part, or I have a part and I want to replace it with an assembly? Well, we can utilize the command replace components to do this. And it's very easy. We find the component that we want to replace, right click on it, and right in that right click menu you will see replace components. One of the benefits of this is I can replace all instances of that component, or I can replace just the selected instances of that component with another component. Another way to replace these components in our assembly is to use save as. So if I have the assembly open, I open up the component that I'm going to replace with a new part or assembly. I can perform a save as, and what a save as will do is it'll allow me to specify a new name. It will also update the assembly to reference that new component that I just saved out. And the difference between save as and save as copy is just that. Save as copy is not going to update the assembly if the assembly is open. We can also use the option reload. So if I'm working in a multi-user environment and not utilizing a data management solution like Enterprise PDM, we may see some changes and we are not working with the latest version. Reload can be used to replace components in that assembly to see those reflected changes. It's also a great way to go back to the last time you saved a part or an assembly. So if you've made some changes, realize you don't want those changes, you can go to File and then Reload to reload that last saved version. We also now have an option called Make Independent. And so this allows me to, if I have multiple instances of a particular component in my assembly, it allows me to make one of those instances independent. So if I need to make a change to just one instance, that's going to be a new part. So Make Independent allows me to save the time of replacing that instance and simply just save it out as a new file with a new name. And we can access that by right-clicking on the component and choosing Make Independent. So lastly here, for some tips to increase our productivity, pack and go or copy tree if we're utilizing enterprise PDM. What's really great about this is we can gather all the related files for that design inside that model, and we can copy those to a new folder or zip file. And it doesn't actually have to be all the files. We can pick and choose which files we want to bring over. For example, if we have a design that's based off of a previous design, we may choose to copy only a select few components from there that are going to change. Some of those might be library components. We don't necessarily need to make a copy of those library components because they're common referenced. And so we can utilize pack and go or copy tree to just move over what we want for this new design into the new folder. This saves us a lot of time, so we don't need to go in, create the new model, and then we can ensure that the references are correct for that new design. So this takes us to mate errors in the assembly. And I think this is a topic that can be quite frustrating to tackle. Right? Get in here and take a look at some of these mate errors. If you've ever added a mate to an assembly that over-defined the assembly, it blows up the assembly design tree. And so going through this section here just to discuss a little bit, we want to take a look at some of the best practices there and also simplify the mate errors to help us understand the mate errors a little bit easier so we can get in there and fix those problems. So here I've just put together a little table showing us the different mate errors that we have, as well as a description about those. The first one that we have is a missing reference. And this is commonly seen if we replace a component with a different component that does not have similar geometry. We may have some mates in there that are missing some of those references, and so we need to go in there. We need to either delete those mates or reassociate those to a new face for the new part that we replaced, however we want to fix that. But it's important to know that these mates cannot be solved. So even though they exist in there, they're more or less dangling, if you will, so by missing that reference. Also, over-defining. So if we have a over-defining mate, we may see an error marker listed in the design tree, and this can also bring a plus symbol prefix next to the component name. And so anytime we see an error marker on a mate in the mates folder or in the design tree, this tells us that the mate is over-defining the assembly and it is not being satisfied. It's not being solved. And the opposite of that, I guess you could say, is the warning mate error. So this tells us that it is over-defining the assembly, but that mate is in fact being satisfied or it is being solved. So there's a big difference between the two of those. And we'll take a look at an example going back to that gearbox in SolidWorks so I can show you a couple of these items. We also have suppressed mates. Now they're not really errors, but they can still cause us some problems if we forget about them. And we see these as grayed out in our mates folder. And of course, because these are suppressed, these are temporarily deleted, they're not being solved. But we can have multiple suppressed mates in there and it can get a little bit confusing, so it's good to manage these, know what mates we are suppressing. If we don't need the mate, let's just go ahead and get rid of it. So a couple different approaches that I like to take on fixing mate errors. I like to suppress the over-defined mates one by one, so mates that aren't being solved. Taking a look at suppressing those one by one until the assembly is no longer over-defined, and then I can go back and start adding those again and figure out why it's becoming over-defined. We can also change our perspective to look at the mates rather than the features for each component in the design tree. And you can do so by right-clicking at the top of the design tree, going to Tree Display, and then choosing the Perspective Mode option. We can also utilize Mate Expert, and this helps us identify any problems that we have with our mates. It shows us our over-defining mates as well as our mates that aren't being solved. And to access this command at any time, I can right click on the mates folder if I have an overdefined assembly, and we will see mate expert listed. We can also view mates for a particular component, and this is seen on our context toolbar. If I left click or right click on a component, I have a little paper clip with some glasses, and that is the view mates command. So let me go ahead and jump into SolidWorks here really quick just to show you guys a example of overdefining the assembly. So here I have this output shaft. We've centered it with respect to the gearbox. I'm going to go ahead and overdefine that by adding a coincident mate to this. Now the reason why I want to bring this up here is there's a message box that will pop up, and I think it's misunderstood a lot of the time in how or what that message box is asking. And so I'll go ahead and do this. In the message box that we see here, the selected mate cannot be successfully added. Would you like to force this mate to solve? That's the key sentence there. Would you like to force this mate to solve? It's actually already created the mate for us. So a yes or a no, I'm still going to have a problem in there. But a yes is going to force the mate to solve. A no is going to put the error marker on that particular mate in the design tree. So if I go ahead and hit yes, you will see that output shaft move into position to satisfy that particular mate. And if I look over here in my mates folder, I can see that it is in fact being satisfied, right? It's just a warning, but it is overdefining the assembly. And so now I have the mate that I added earlier, the coincident mate, that is now the one with the error. That is the one that is not being solved. If I were to undo that and hit no this time, we would see that the components stay in the same position, and it shows me that that mate that I just created has an error. It's overdefining the assembly. It is not being solved. So again, if I right click on the mates folder, I can take a look at the mate expert. Right? The mate expert again allows me to find and troubleshoot those problems that we have with our mates. Simply just hit diagnose. This will show me a list of mates that I have that are overdefining. In bold, I will see the ones that are not satisfied. I also have the not satisfied or not solved mates down below here as well. By right-clicking at the top of the design tree, like I said, we can go to Tree Display, and I can choose to view mates and dependencies rather than features. So if I check this box and we expand one of these components, you'll notice that I'm looking at all of the mates instead of a mates folder with all of the features. So just a different way to take a look at these components within our design tree can be quite helpful for fixing these mate errors that we have. And then again, through the context toolbar, if I left click, right click, I can choose view mates for that particular component, and this is going to show me those mates that I'm using for that motor mount. All right, managing large assemblies. I think this is one of the more popular topics that come up, especially in technical support. I know we're always looking for how we can improve these assemblies, how we can reduce the open time, the update time for these larger assemblies. And so as we go through this, we're going to take a look at some of the best practices there for making these more efficient. Before we get into that though, I want to bring up this flow chart here for opening an assembly. And we just want to take a look at the different steps that our assembly has to go through as we load this. So first we open the assembly, we load all the reference parts and sub-assemblies, and then if there's no components that have changed since the assembly was last saved, we're finished. However, if we have any changes, we need to update any of the out-of-date components. We have to go through and solve all the mates and position those components. And then if we have in-context features and or assembly features, we need to update those. And if those reposition components, we need to solve the mates again and then go back through the same couple steps there. Solve all the mates, position the components, and update any in-context features or assembly features. And then finally we can paint the display for the updated assembly so we can see the visualization, the visual representation of that, and then we're finished at that point. The reason why I bring this flowchart up is for reducing the amount of time it takes to open these assemblies. We really need to take a look at this flowchart as individual steps. If we can minimize the amount of time we are in each of these stages, we can reduce the overall time it takes to open these larger assemblies. So let's take a look at some of the best practices for this. The very first one, and one that I always bring up, is to work locally. Always work locally. A data management solution will do this for you. This is the best solution. Enterprise PDM will automatically copy those files from the network, from the server, and move them locally so you can work on them. We don't want to rely on our network, the bandwidth, the amount of traffic, the handshakes that we have to define the opening time for our assemblies. We work locally, we're going to see a significant improvement in that area. Also, utilizing large assembly mode and lightweight mode. Large assembly mode is a way for SolidWorks to simply just toggle some system options on and off. Help reduce some of the delays that we may have when manipulating the model, rotate, panning, zooming, all of that good stuff. And then lightweight mode, right? Large assembly mode actually utilizes lightweight mode. Lightweight mode is just a lighter weight component that is loaded up. So rather than seeing all of the features in the design tree, it's a lighter version of that. Now we can also utilize large design review in many cases, especially for our larger assemblies, or maybe for an assembly that just takes a little while to open up and we need to quickly open it up and just review it. We can utilize large design review, and I'll show an example of that. We can also create simplified versions of our components, and by doing so we can take advantage of what we call advanced open. So a great way to utilize those simplified configurations within our parts. Assembly visualization can also be used to take a look at rebuild time for each component in the assembly, as well as the amount of detail that goes into that with the graphic triangles. SpeedPack sub-assemblies is the lightest form of a sub-assembly that we can create. And really I recommend, if we are using some purchase parts, purchase assemblies in our top level assembly, we want to create a SpeedPack configuration for those, because those parts aren't going to change. And if there's a lot of, those assemblies aren't going to change. And if there's a lot of detail that goes into those assemblies, it's just more information that needs to be loaded up by SolidWorks each time we load that top level assembly up. So we can utilize SpeedPacks for those purchase components that we download online. We should also be taking advantage of display states instead of configurations where it's applicable. So if we are just hiding or showing certain components in an assembly, there's no need to use configurations to suppress or unsuppress these. And we can also, if we're utilizing display states, take advantage of a couple options. The ability to not load hidden components when we load the assembly, and also unload any hidden components, because when we just hide a component in an assembly, it actually keeps all the information about that component loaded, and we can choose to unload that if we would like. We should also be converting our data for our file set, our model, to the latest version of SolidWorks. If it's an earlier version, when we open that assembly inside of SolidWorks, SolidWorks actually has to prepare that model for the new version coding. And so that takes time. It's an extra step that we have to go through. We can also minimize the amount of components, the amount of mates, by utilizing multi-body parts or weldment parts. And so if this is something that we can take advantage of, we definitely should. So let me jump into SolidWorks really quick here and let's take a look at some examples. Here I've got a miter saw, again right through that recent documents list. What's nice about the recent documents list is, again, I can pin these documents. We can also access the same options that we see when we do a file open through SolidWorks. So I can change the mode. I can load it up resolved. I can load it up in lightweight, large assembly mode, large design review. We can also specify the configurations or choose which display state we want to open it up with. And then I have a couple options here. So for any sub-assemblies that contain a speed pack configuration, we can choose to check use speed pack, and when I open this top level assembly, all those sub-assemblies will use their speed pack configurations. It's a huge time saver. That way I don't need to create multiple configurations of my top level assembly, ones that reference the speed pack and ones that don't. We can simply just check this checkbox. And if we utilize different display states here to hide certain components, if I don't want to load those components to save me some time, I can check the do not load hidden components option. Now for this, I'm just going to load it up resolved. And it takes a little bit of time to load this up and fully load it before I can start working with it, rotate it, zoom in and out, pan it, take a look at the design tree. It's anywhere between 30 seconds and 35 seconds. And I want to show this simply because I also want to open this same assembly using large assembly mode and lightweight mode, just to show the difference in time there that it takes to fully load the model and start working with it. So we're almost there. Perfect. Now I can start rotating that. So you can see that took quite a bit of time. Not too many components here. It's quite detailed, but took quite a bit of time. 30 seconds seems like 5 minutes sometimes. Let me go ahead and close this, and we'll go through and open it again, but this time I'm going to use large assembly mode. And remember, if I use large assembly mode, that's also going to load my components in lightweight. So just less detail that is being loaded up with these components. Less information, less time it takes. So here it still takes a little while, but it is definitely less time than loading it when it is fully resolved. I believe this is somewhere around 18 seconds. So just about cutting the time in half there before I can start working with it. And we can see over here in the design tree, right, I've got these lightweight components. We take a look at one of these components, you'll notice that none of the features exist in that design tree. And so that's what our lightweight components do, just a lighter version of that. Now another way that I could open up this assembly is to utilize large design review. And so by doing this, this is the lightest form of opening the assembly. This allows me to gain access to some of the design review tools that we need. So things like being able to navigate the structure of the assembly through the design tree, measure distances, create cross sections, create snapshots, walkthroughs. If we want to selectively open a particular component to make some changes, we can do that as well. And you'll see that as soon as I hit OK here, it's almost instant in the time it takes to open that assembly. So immediately I can start working with it and grab all the necessary information that I need from it. Now here we also have a base for our miter saw. And I want to show you with this part an example of creating a simplified configuration. So this part contains a lot of detail. I've got the graduations here, I've got certain fillets, some holes that may not be necessary to see at the top level. And so we can create a simplified configuration to suppress some of these features. One of the big benefits there is if we take a look at feature statistics, right, I reduce my total rebuild time dramatically. So we're looking at a little over 1.5 seconds there for the simplified version. If I jump back to the default configuration, we're at 8.3 seconds. So a huge time saver there just for the rebuilding of that part. What's great about this is I can utilize that in my top level assembly. So if we take a look at our base assembly, if I want to open this assembly up and use all the simplified versions of the parts that I have in this assembly, we can use what's called the advanced open. So if I choose advanced under configurations and hit open, there's a checkbox here that I can check to use specified configuration for part references when available. So if I have a part in this assembly that has a simplified configuration, it will go ahead and use that simplified configuration. So I hit OK, and we will see as soon as this assembly opens up that I am in fact using that simplified configuration of that base part. So those are some best practices to help us improve our opening times, but what if we're making some changes to the assembly? How can I reduce the time it takes to update those? Well, here's a couple best practices to keep in mind. We can limit our in-context feature use, right? If we have components without these in-context features, we don't need to rebuild their feature tree each time that we jump back and rebuild the assembly. It's also important for us to limit the amount of top-level mates. And we can do this by using rigid sub-assemblies. This is why if you have a assembly that you bring into your top level assembly and that then sub-assembly has movement, we don't see that movement immediately. It's because SolidWorks is treating that as rigid. It is keeping the mates at that sub-assembly level. Now the opposite to that is to make it flexible. So we have that movement at the top level. And what this does is it brings the mates in that sub-assembly and solves them with the top level mates. So we're just adding to the amount of information that needs to be updated each time. We also want to avoid mating to pattern instances and or assembly geometry. This creates an order dependency where our top level mates are solved, assembly features are solved, and then mates are solved again to update the position for those components. Very similar to what we saw with that flow chart. So we want to try to avoid this if we can at all possible. I know sometimes it's not possible. This is how we need to define it. But if we can, let's try to mate to something else. We can also choose to suspend automatic rebuild. So suspend automatic rebuild we can use for in-context features. If I right click at the top of the design tree on the assembly, you will see suspend automatic rebuild. There's also an option available for us in our system options. Do not rebuild when switching to assembly window. Can be used for large assemblies. And so if I make these changes and I come back to the assembly, if I don't want to rebuild at that time, I want to be able to control that. We can choose to turn this option on. We also want to reduce the graphical demands of our assembly. We do this through image quality through our document properties in our options. We can reduce that amount. What's great about the assembly level is I can reduce the image quality for all the parts as well. So I don't need to go into each part to reduce that. We can also utilize assembly visualization, and we can add different columns for graphics triangles or rebuild time, which can help us improve the update time for our assemblies. And then using Assembly Expert to help us find our bottlenecks, see how our assembly is performing. We can take a look at things like the number of top level mates, the number of unique documents that we have in our assembly, the number of flexible sub-assemblies. And so a great way for us to really evaluate that assembly. So I hope you guys enjoyed the presentation. It was a great use of your time. As always, if you guys have questions, feel free to contact us. Have a great day.